Okay, let's look at this fraction, 34 over 6 minus the square root of 2. A second rule of radicals is leave no radical in the denominator. No radical in denominator. Well, how do we get rid of that radical from the denominator? If this is a binomial denominator, and it is, don't try to figure it out. Just remember what to do. We need to multiply this fraction by something that represents 1. And the something that represents 1 that will eliminate the radical from the denominator is this binomial with an opposite connecting sign, 6 plus the square root of 2 over 6 plus the square root of 2. So this fraction now represents 1. This 6 plus the square root of 2 is called the conjugate of this denominator. So now let's multiply. The numerator, I'm going to suggest the multiplication, which is 34 times 6 plus the square root of 2. And in the denominator, we're going to use FOIL. 6 times 6 is 36. The outer product is 6 square root of 2. And the inner product is minus 6 square root of 2. And the last terms is a minus. Radical times radical is the radicand. So this becomes 34 times 6 plus the square root of 2. And the denominator is, these cancel, 36 take away 2 or 34. So look at these. The reason why this radical disappears from the denominator is because of foiling. We have a binomial with a negative connecting quantity and a binomial with a positive connecting quantity. So this always leads to a difference of 2 squares, the square root of 6 and the square root of the radical 2, difference of 2 squares. And the reason I didn't multiply out the numerator is I was hoping something like this would occur. These 34s cancel, and the final answer, or best answer, is 6 plus radical 2. Another rationalization problem is the square root of 7 minus 3 over the square root of 10. It's all right to have a radical in the numerator as long as the perfect squares have been taken out. It's not allowable to have a radical in the denominator. The difference between this problem and the previous problem, this denominator is binomial, this denominator is monomial. So again, we need to multiply by a 1, but the 1 in this case is the denominator radical 10 over itself. So let's multiply out the numerator. And this time I'm going to actually distribute the square root of 10 times this. So I'm going to have the square root of 70, radical times the radical, square root of 70. And then multiplying these two together, I would have minus 3 radical 10. Can't extract any perfect square from that. In the denominator, any radical times itself is the radicand. And there is no cancellation possible. That is the final answer. And for our last problem, let's FOIL out 2 binomials. The square root of 7x add 2 times the square root of 7x minus 2. Well, it looks like we have the sum and the difference of the same 2 quantities. I bet you know what this is going to lead to, but let's just do it out. First terms multiplied, square root of 7x times the square root of 7x is just 7x. The outer product is minus 2 times this. The inner product is plus 2 times that. And then the last terms is minus 4. we can simplify because these cancel out, and I'm left with 7x minus 4. Basically, we have the sum and the difference of the same two values, which leads to the difference of the square root of the first term, and the square root of the first term is 7x, and the square root of the second term, which is 4.